Well, good morning, everyone. I hope you've had a good day so far. In our time together today, we're going to continue our discussion on ABAP programming concepts. I've made some adjustments here to the SAP GUI. We'll have to see how this plays out, but I've tried to increase the font size to perhaps make this a little bit more readable for everyone. Any questions before we get going here this morning? All right. Well, we have a lot of important things to cover to get you ready for your next homework assignment. Where we left off last time was talking about the standard types that are given to us as a part of the ABAP programming language. And I think we left off right at this point last time, and we had established that there are complete and incomplete data types. And the distinction between them is that an incomplete data type, we can't just give the name of the type. We are going to have to supply additional information related to the size of the desired data type. The key here being, for example, using C as an example. C is an incomplete type. We need to specify a length. So if we were to create a data object of type C, we would have to tell it the maximum number of characters to accommodate. That is distinct from the data type string, which is dynamic in its length. And so because that is a complete data type, we do not specify the length of that. And in a moment here, we'll come back to and discuss the distinction between those two. We have an X string, hexadecimal string, which is a dynamic length byte sequence. I don't know that we'll do anything with that this semester, but if you think about something that I told you last time, which is that the reason why the size of some of these data types is so large is because of the desire to do file processing with them on occasion. Well, an X string gives us the ability to go out and grab a binary file and in some way incorporate that into our work that is underway. X as a data type is a byte sequence up to 64K. So really you're looking at the same kind of relationship between C and string that you see between X and X string. And like the comment I just made about X string, we probably won't use X as a data type in our work this semester. D is a data type for dates. Dates are stored in the format YYYYMMDD. So if you were going to assign a date to a data object, literally in your code, this is the way you would render what you put on the right side of the equal sign. So date is stored in that format. Now when we render it to the screen, we can affect how it's rendered and change that. But as far as the way this is actually managed under the hood, that's the way we specify it and that's the way it's stored. Similarly, T for time data is 6 characters in the form 2 digits for hour, 2 digits for minute, and 2 digits for second. So as you can gather, that's going to be using military time because there's no AM or PM that is stored in conjunction with that. Packed number. Packed numbers are distinct and can be very, very useful to us in ABAP development. A packed number is a precise whole or floating point number up to 16 bytes. And I need to explain to you the mechanism whereby the length of packed numbers are specified and also the significance of packed numbers. Let's start with the latter one of those, which is the significance of a packed number. So what will happen in my program is I will define a data object to be a packed number, and I will express the size of the packed number, and then if it is to be a decimal number, the number of spaces to the right of the decimal point. When I specify the length of the packed number, I have to understand how the number is used. With packed numbers, if I specify a packed number of size 8, what happens is that number gets multiplied times 2, giving me 16, and then I subtract 1 from that for the sign bit. So a packed number of size 8 actually stores 15 digits. So the way this works is I take the number of digits I desire. So if I need a 12-digit number, I would define a packed number of size 6. Now, why use a packed number as opposed to an integer or even a float? If you have done various kinds of development in different programming languages, you know that computers and the way they store numbers sometimes lead to very, very interesting scenarios due to the management in particular of what's to the right of the decimal place. And you might expect the outcome of a sequence of math to be 2.5, and in fact what the computer has is 2.4987236778 because of the way it did the calculation, characteristics of the processor, and so on. We can't have this in the kind of calculations that are often part of our ERP systems. You know, we're doing things like calculating people's payroll, doing a lot of monetary manipulations where, you know, we need very, very precise numbers, and we need them to work the way we were all taught how numbers work in math class, which is why it's really hard to understand outcomes that you get like this out of the computer from time to time if you don't really understand all of the complexity of how computers store and manage numbers. So what packed numbers give us the ability to do is to tell the computer, I don't want you to use your normal way of handling numbers. Packed numbers are essentially stored in a format very, very similar to character strings or other character-based data. Normally, in most programming languages, if you ask the computer to tell you what 3.3 plus 2 is, the computer's going to send that to a math processor that's built into its microprocessor and going to give you back an answer. That is not the way mathematical manipulations work with packed numbers in ABAP. If I am doing math with packed numbers on ABAP, ABAP uses its own ABAP engine to do the math. And it does the math to make it consistent with the way that we would get the outcome if we were to do it with a piece of paper following the normal rules of mathematics. So ABAP does not turn the math over to other processors for fear of getting results like this when you worked with packed numbers. So packed numbers are something that is somewhat distinct to ABAP. There are other programming languages that had this concept, most notably COBOL has this concept, and it is a different way of rendering and managing numbers that kind of takes it out of the purview of the normal way that computers process numbers and puts it under the control of the language's processing engine.
Does that control the round-off errors?
Absolutely. We have control over that in the same way that you would be told how to do that in math class. And I don't know if you've ever seen this in programs before, but I've had students in basic programming classes where I tell them to write a program to calculate the sales tax, and it's 7% sales tax on a $2 purchase, which we would all know means the answer is 14 cents, and their computer program says the answer is 14.2 cents, and they can't figure out why. And it's hard to explain why. This solves that. You get answers that are exactly consistent with what you would expect. Any questions about this? Yes?
So in this problem that you did up here, would you have 15 binary digits or 15 decimal digits?
15 decimal digits. 15 decimal digits. Or for sake of everyone, this could be a 15-digit number. Okay. Now, So what we have done so far is talked about the data types themselves. You either have already or will see something very similar to this in your textbook. So there are other places that you'll have as a reference to go along with what we discussed. But obviously the next big thing for us to talk about is actually how to make these and work with them in our program. Before we do that, though, I realize I have another slide here. How do I know when I should use C and when I should use string? So let's talk about what we know about this. With C, if I create a data object of type C, I have to give it a maximum size. So I might say I want a first name data object of size 25. If I say I want a first name data object of type string, the length of that is practically unbounded because they can have 65,000 characters. So the question becomes, how do I know when to use C and when should I use string? And there's a trade-off here. There's a trade-off between the efficiency of my program and flexibility. You know, if I were to say the first name is of type string, somebody could type in a first name that's 400 characters long. Do I really want them to do that? It gives me maximum flexibility in case first names that are 400 characters long become commonplace, but I'm giving up efficiency because my program is going to have to be able to function with first names that are that size, which now all of a sudden is going to raise all kinds of issues, which is when I create a report that's either going to be displayed to the screen or perhaps printed out, how do I account for that first name that now could be 400 characters long? So whereas a string is very useful in that it gives us flexibility, a lot of times it does make sense for us not to use that and instead use C and specify a particular maximum length. String does carry with it a fairly minor overhead hit, as every time you define a data object of type string, hidden away in the system is another system managed data object that keeps track of how big it is. So you actually have a hidden variable back there that says, okay, the first name in this case is 22 characters long. And so there's a little bit of a processing hit that goes with it. But the more relevant rule of thumb is, if you know a data object will never exceed a certain size, then use C in conjunction with that maximum size. Now let's think about this for a moment, and in particular think about the kinds of things that we would expect an ABAP program to do and to work with. How is it that we might know, for example, that a first name will never be longer than 20 characters? Or how is it that we might know a last name will never be more than 25 characters? And we know that with pretty good certainty. How is it that we could know that?
I just won't accept anything bigger in this on the screen.
Right, but that's part of the logic of our program and such. But I guess my question, let me figure out a different way to ask it. How could I as a developer know that a first name that's 20 characters long is okay, but a first name that's 21 characters long is unacceptable? And I can know that with certainty that 20 is a good length for a first name as a maximum value. What's another part of my programming environment that plays a role in this?
The fields in the database?
Fields in the database, okay? So ultimately, when we define a database table, we're going to have to say things like, this field right here is the first name, and it can hold up to 22 characters. So whereas you might think that the flexibility of a string is really, really useful and really, really helpful, if I'm asking the user for their first name, and I know I'm putting it into a database table, and I know that database table will only accept first names up to size 22, then I should set the name of the first name data object to be consistent with what I know about what I'm going to do with the data. We'll come back to that theme, and in fact there are ways to manage this in ABAP that make this very, very useful. But this idea of tying the definition of our data types to the destination of where the data is ultimately going to go is a critically important part of development in ABAP. And so we will find later on in this semester, as we're writing programs, we will be making visits to databases a lot and looking at the metadata to determine design and other features of things and that would be relevant for our program. And so that's this question. How could you know with certainty a maximum data object size? Well, if it relates to a field in a database table, we can look at the metadata for that database table and know what our requirements are. So you'll get an opportunity, obviously, as the semester goes along to work with these. And I would expect that there may be instances where you would use C this semester. There would be instances where you would use string or other data types that are user-defined that we'll come to as we progress in our knowledge. Let's talk a little bit about working with D and T, the data objects, or excuse me, the data types that allow us to work with dates and times. Like packed numbers, this data is actually stored as characters and not as numbers to give us precision. But ABAP realizes that you may need from time to time to do math manipulation on dates and times. So even though this is stored as character data, math manipulation is possible. And the way math manipulation is going to work with D and T is if I add to a date or subtract from a date that is based on days. So if we, for example, were to start with a variable that was set to January 1st, 2018, and we took that data object and did +5, that would move us 5 days into the future. Or we did -7, that would back us up 7 days into the past. When I'm working with times, I can add or subtract to that, but what I am adding and subtracting is seconds. So if we started with noon, and then we added 180 to it, it would now be 12:03. Okay? So that's the way those work. Even though they're not numbers, I can do math on them. Questions about any of those things?
If you can't do yours, you'd have to do 365 days.
Mm-hmm.
Okay.
Now, there are functions and modules that are in the system that I might be able to leverage to do more advanced calculations, but this is just the rudiments of it. So let's look at now how we actually create these things in our program. When I am creating a data object, the keyword that begins the line of code is data. Once again, a reminder, we render keywords in all capital letters. So data, then the name of our data object that we're creating, first name, last name, age, whatever have you. The keyword type, and then the type specification that comes from what we were just talking about. So for example, this would be a perfectly valid line of code that would create a data object called age of type integer. So this would let us store the number 7, the number 42, the number 118 in this data object because it would take in whole numbers. I can supply an initialized value. The syntax for that is, as you see here, I extend the sentence with adding the keyword value and then what I want the value to be. So in this case, I've created a data object called siblings. It is of integer type, and I have set it to the default value of 7. With an incomplete data type, I have to add syntactically relevant specifiers So if we take this apart, ignore the value part of this. Data state type C, incomplete data type, so I have to let the system know the length 2. And I could drop a period there to end that sentence, and that would then be a fully executed data object creation for a variable called state. If, like I illustrated on the line above, I want to initialize it to a value upon creation, I can continue with the syntax of value and then supplying the value as you see here. One of the things that we have to be very, very careful about is with incomplete data types, it is not a syntax error to leave off the length, but the system will assume a default length that is probably not what you had in mind. For example, type C without a length specified gives you a character string of length 1, which in this case would be really problematic because, as we can see here, I want to stuff 2 letters into it. So the rule of thumb is, even though there are default lengths that will come into play, we never want to rely on that, and we always want to be explicit about specifying the length. Even if I want a single character length variable, I still should put data first initial type C length 1 and be very, very explicit about that for the sake of the maintainability of my program. Now, I will show you this, that we can employ a change statement here for the sake of data object creation. When we do that, the way we format this is as you see it here on the slide. We have the data statement, a colon, which tells us this is a change statement. And then on every line, we are going to define a single data object, with every line ending in a comma, except for the last line, which ends in a period. So it really does not matter, and you will see ABAP programmers that do it either way. Some people like every data object to have its own distinct data statement, which is perhaps what's illustrated here on the top block. Or you can do it with a change statement as illustrated here. But the key is, if you are going to use a change statement for this, make sure you indent it as is illustrated. Yes, sir?
Can you define variables of different types in a change statement?
Absolutely, yeah, because basically every one of these stands on its own. So yes, you can have a wide variety of different data objects created here of varying types. Absolutely. There is a keyword. Well, let me point this out. There are other variations on the data statement that are considered obsolete. For example, there are ways to specify length that use parentheses. That's considered deprecated or obsolete, and in fact won't work when we start working with ABAP objects. I bring that up because just in case you wind up looking at something on Google or some other source that's showing ABAP code, and you see some things that look very different than what we're showing here, don't use them, because they are older techniques that are now considered deprecated, so we should be employing what it is that we see here. I can use the keyword like to declare a variable that is based on something that already exists. So here, data state 2, which is like state. So what the system's going to do is say, oh, state, that's the name of a data object I already know about, and it's going to go and say, oh, that's of type C length 2. Now the key thing to realize here is what I've put at the end here. only the data type is copied, not the default value. So in this case, state 2 is type C length 2 with no value set at this point. Now you might be inclined to say, why would I need that? You know, to me that looks like I could just say data state 2 type C length 2. And I agree with you. What we are going to see, though, later in our work that makes this just absolutely fabulous is I'm writing a program that is going to be putting data into this database table right here. And the name of this field right here, let's say, is MAKT, and it's found in a table called MARA. I can say data, give it a data object name, data, my data, like Mara-MAKT. And it will create a data object that is parallel in type to something that's defined in a database context. So although it might not seem, and we'll talk about that in much more detail later, so although it might not seem like this would be that useful, this ability to use like is very, very powerful because it allows us to leverage the specification of things that are already in the system. Yes, sir. Do you have a question? Somebody over here I thought had a question.
Yeah, I was going to say, so it's just easier to do that instead of having to go dig through the database and figure out what data type that.
Yes, and what's that?
The length as well, you get the length.
It's going to get the length. It's going to get that, and we'll talk about this in much greater depth later on. But what it also does is, let's say hypothetically that this table, this field is designed to be 12 characters long as a maximum length. If I write a whole bunch of programs that reference this field, and at some point in the future I decide that I need to go back and change the size of this field to 20 characters, if I have defined my programs to make the length of my data object match the length of this field, as soon as I update this database table, I've just updated all of my programs that work with that database table. So that's the real virtue of using like when we can. With the kind of really simple programs we're going to be writing in the next week or two, we may not have any reason at all to use like, but later on this semester, we will make very, very heavy use of this as an option for data object creation. When specifying default values for numeric data with decimals, the value must be placed within single quotes. Okay, can anybody gather, anybody tell me why that would be?
Oh, you end a statement with a period.
I end a statement with a period. So if I were to put data pi type, whatever the floating point is, I think it's f, value 3.14, as soon as it saw the dot in the 3.14, it would think that was the end of the statement and ask me what that 14 was doing hanging out at the end of my statement. So because of that, I have to put floating point numbers that have a decimal point in single quotes. Okay, let's look at a couple more examples and then we may put some of these in an editor and play around with it. So here's a more complete template for the data statement that I gave you on the previous slide. Data, name of the data object, keyword type, then the data type specifier, and then I really have three common extensions. And once again, as I observed last time, I'm not telling you this is exhaustive. You could look at the definition of the data statement, and you may see other things that could come into play as well. But the more common ones are a length specifier if it's an incomplete data type, if it is an incomplete data type, or a packed number that has numbers to the right of the decimal, I specify the number of decimal places. And then value is used for the setting a default value. Note here the ability to precisely specify the number of digits to the right of the decimal place. It also gives me protection when I'm doing calculations on money and I say I want my answer rendered to 2 decimal digits. That's what I'm going to get. I'm not going to get all of this other stuff right here. I'm going to get answers that have been rounded to be the number of decimal digits I specified. So I could specify a packed number of length 7, which if we do the math on that, that means 7 times 2 is 14 minus 1. So I know I'm going to have 13 digits. So I could say type P for packed, length 7. So now I know I have 13 digits. Decimals, and don't let this trip you up. When I specify the number of decimals, I don't do the times 2 minus 1. I just put the number of decimals I want. So I might put decimals 3. So I would get a number that's 13 digits long, but 3 of those digits are to the right of the decimal place. So I have 10 digits to the left and 3 digits to the right. And then if I wanted to, I could assign it a default value. So let's look at some of these that I have on the slide here. So here's an example. I create a data object called text buffer. I set it to be type string, and I give it a default value of text. I create a data object called count. It's of type I, and I set the initial value to 1. Then, similar to what I just said a moment ago, I create a data object called price. It's packed number. I set it to be length of 8 with decimals 2 with the value 1.99. This is illustrating the putting decimal values inside of single quotes. So these are perfectly valid data statements. Now let me observe as well that I really do question the length of price in this instance. 8 times 2 minus 1 is 15. 2 decimal digits to the right, that means I have 13 digits to the left of the decimal place, which is going to give me prices that extend into the 369 billions, is that right? So think about your muesli company that you were working with for ERP Sim. You clearly weren't pricing boxes of muesli into billions of dollars. So in that context, this is way too big a packed number. And we want to be efficient about our use of space. Probably a more reasonable packed number in the context we were just discussing would be maybe 3, because then I would have 3 digits to the left of the decimal, 2 digits to the right. If I go down to 2, now I have a problem, because 2 times 2 is 4, minus 1 is 3. If I still put 2 decimals to the right of or 2 digits to the right of the decimal place, now I can't have a box of muesli priced at $10 or greater. And that would perhaps be a reasonable price. So we do have to be very, very careful to think correctly about packed numbers when we are specifying their length. Oh, here's an example of deprecated stuff. It used to be that you would specify the length of the data object by putting it in parentheses after the name of the data object. That's deprecated. SAP draws a distinction between obsolete and deprecated, and so this is considered deprecated, which means that if you're maintaining old code, you might see this, but don't write code that looks like this anymore.
When you're dealing with different countries, and some countries have inflated currencies where you have to spend $1 million to say a box of cereal or something like that, do you just have different programs running for different countries, or how do you?
You're getting to a really good point that we actually, I don't know that we'll wind up talking about today, but if not, we'll hit on Monday. We're writing programs potentially for global companies where we have to consider internationalization. Let's assume we wanted to write a program that just real simply asks the user, what do you want a price of muesli to be? And then we gave them a dialog, gave them a field to type a number into. Well, what do you want the price to be? is in English. So what do they do if they're in France or Germany or some other country? And we'll talk about how we internationalize our programs. So you're right, that may also have an impact on the design of our program. We can write multi-currency programs. That gets beyond what we will do in this class, but it's actually not that hard, and I'll show you the technique here. I think we'll probably get to it on Monday. I can tell you that, I guess this is about 5 years ago, I had a student in the class who was working for a company that was doing ABAP development, and she said that they had recently expanded outside of the United States, and they were having to go back and update all of their programs to be internationalized, and that their coding standard moving forward required them to write their programs in a way that would be supportive of that. And I'll show you how to do that. It doesn't add a lot of extra work, but it does change up some of the ways that we do things. So that's a very good thought, and we'll come back to it and look at it in more specifics. Other questions? All right, I'm not going to type a real simple program into the editor at this point because it would just look like what's here on the slide. But let's add a couple of more tools to our toolkit, and then maybe we'll write a quick program together. How does math work? You have the same mathematic operators that you have seen in pretty much all your other programming languages. There are some distinctions, however. We have the traditional plus, we have the traditional minus, we have the slash, which does division, and depending upon what programming languages you are used to, let me explain that the slash does division, giving us a full and complete answer. So 3 divided by 2 using the slash will give us the answer 1.5. Double stars are used for exponentiation. So 3 star star 2 is 3 squared. Div is integer division. So it's the way that I can do division and throw away the decimal part if I don't want it. So 3 div 2 is 1. Or let me pick you a better example. 17 div 3 is 5. So we just get the whole number part of the answer. Mod gives us the remainder. And you've used mod, I'm sure, in other programming languages, and I'm sure you've seen the concept behind the slash and the div in other programming languages, although some programming languages use different symbology or have slightly different rules. We can, of course, use parentheses to set the order of precedence, and this is when I tell you that, in other classes, maybe you talked about order of precedence in great detail. And maybe at some point in your programming career, you have memorized or learned a table showing the order of precedence. Our rule of thumb is really straightforward. If there could be any question about the order of precedence, just put parentheses in there to make it clear. Okay? We want to write maintainable code. I don't know who was the first person to start doing this, but I've noticed that on Facebook now, there's like all these people that want to post, what's the answer to this math problem? They throw up this math problem there, and then everybody gets a fight over it, and ultimately it has to do with what's the order of precedence. And one of the things that people have discovered from that is, and I don't know if any of you know this, the order of precedence has changed. If you talk to someone who went to elementary school 30 years ago, they learned a different order of precedence than is used in mathematics today, which just further adds fuel to the fire of those Facebook debates. So our rule of thumb is we would never want there to be a Facebook debate about our mathematics, because if there's any question at all, if we're doing anything even moderately complex, put in parentheses to just make it crystal clear how you want this calculation to be conducted. Now, I mentioned this as an aside the other day. One way that ABAP is unique from some programming languages is that operators and parentheses are considered keywords. So, for example, div and mod should be typed in all capital letters, and if you neglect to do that and hit the pretty printer, it should turn it into all caps, because it will see those as keywords in the language. There's obviously no casing with operators and parentheses, but they also are considered keywords, which leaves us the rule of thumb. They have to be separated from other statement elements by at least one space. And really more precisely, that should say by one space. The exception being if we're at the end of a line of code. Now, and I'll show you some examples of that. There is an ABAP statement called move. And remember I told you that every ABAP sentence begins with a keyword? In very early versions of the ABAP language, that was absolutely universally true. And so you did variable assignment like this. Move var2 to var1. And this would be how you would copy a data object from one to the other. We can still use this syntax. I don't know why you would. Later on, I will show you actually a variation on this that is really useful, that we can use to do things like copy an entire database table in one operation. But for working with primitive data objects, this makes no sense. What we would do is instead, the more common from what you have seen in other languages, this right here, var1 equals var2. So you'll notice this violates what I told you previously about every ABAP sentence beginning with a keyword. There's no keyword at all in this particular statement, except for the equal sign. The equal sign is actually considered a keyword. Yes, sir?
So, in that statement, is that being passed by value or by reference?
These would be, to a certain degree down here. I don't know that it matters really, but I'm thinking the answer probably is passed by value, because we're not referencing the same data object here. These are now going to be two distinct data objects that are both set to the same value. So this would have to be passed by value. But later on, we'll get to variations on this guy right here that allow us to specify which of those mechanisms we want to employ. But I think it's fair to say in both of these, as we're looking at now, this would be the equivalent of pass by value. Other questions? All right, so let's see where we're headed next here. Var x equals 3 plus 7 times 2. And here I'm going to say we should be putting parentheses here. Okay? I mean, just to be clear, I think it takes an extra 30 seconds for you to put them in, and then we don't have to worry about should we do the 3 plus or the 7 times first. We just make it crystal clear. If we do introduce parentheses, remember parentheses are keywords, so we might do something like 3 space plus space open parentheses space 7 space star space 2 space close parenthesis period is the way we would actually render that. If I'm working with variables of different data types, the system will do automatic data type conversion. Chances are pretty good that in programming languages you have worked with to this point, you probably spent more time talking about typecasting than you actually spent using it in your programs. And that's particularly true in ABAP. We just don't have this come up as often as you might think, because we're not doing scientific programming, we're not doing mathematical programming, we're doing database programming. But where this will become relevant later on is when we start doing things like putting strings together or other things of that sort. I have a very, very useful command called clear. that if I use that in conjunction with the name of a data object, will reset it back to its default type-related value. Now let's be clear about this, no pun intended. If I have a data object called state that is char2, and I initialize it to tn by way of the value statement, when I do clear state, I get back an empty 2-character data object. It does not put Tennessee back in there. Okay, so clear just wipes it out. And so when I say default type-related value, what I mean is if we're talking a character string, we now have a character string that essentially is null. If we're talking a number, it's reset it back to 0. If we're talking dates or times, to be honest with you, I don't know what it's going to reset it back to, but it's going to reset it back to whatever the default beginning of time is in the ABAP world. I've never really had to worry about cleaning out dates and times. To get us ready for actually writing some programs, here's some functions. I'm just showing you this for the purpose of letting you know there are functions in ABAP. We have an absolute value function, we have a ceiling function, we have a floor function, we have a truncate function, we have a frac function, which gives us just the decimal portion of something. We have a sign function that returns 1 if we feed it a positive number, -1 if we return a negative, 0 if 0. And the only reason I'm showing you that is once again to show you how we would incorporate this into our programming. Data result type I. So I create a data object here of type integer, and then I'm going to feed it a literal number. Result equals, and notice my spacing here. This is why I wanted to show you this. Equals space ceil, which is the name of the function. The opening parenthesis has to butt right up against the name of the function. But then after that opening parenthesis, there's a space. And then in this case, you can see I'm feeding it 3.2. Why is 3.2 in quotation marks?
The decimal.
The decimal. Had to do it in this instance. And so if I fed it a variable, there would be no quotes there. Now, this is a really good point, and I almost corrected this slide because I usually do try and correct it, but I did not correct this one in person. You'll notice on my slide, the funky way that my quotes look here, this is because I'm using PowerPoint, and PowerPoint implies smart quotes. And so that's the quote, that turns it in and out around a value for the sake of making it look pretty. In ABAP, we just have the standard single quote. The reason why I point this out to you is later on in the semester, you may wind up doing some moving of code around. For example, the way we will submit your programs in this class is, I will tell you to write your ABAP program, get it working, send me screenshots, but then I will also tell you, copy your source code into Microsoft Word for submission. And so if you go into ABAP and you do a select all and hit Control-C, and then you go to Microsoft Word and paste it in, depending upon how you have your word processor set up, it might change your quotes to these guys right here. Now, for the sake of homework submission, that's fine. But if 2 weeks later, you're working on another program, and you say to yourself, I'm going to go back and copy a snippet from that program I worked before, and you go back and copy it, you may wind up pasting into your editor source code that has the curly braces in it, and ABAP's going to choke on that. Similarly, if you were to copy this off of my slide and paste it into ABAP, ABAP would choke on it. Here, let's do that for fun, because we could call that fun. Okay, so Control-C, and then I go to ABAP, and we're going to get rid of our hot dog and hamburger, and see what just happened. See, it doesn't like my smart quotes, as evidenced by the fact that it has given me red here. Okay, so you can actually go into your Word, PowerPoint, whatever have you, and turn off smart quotes, in which case you never have to worry about it. Or if you leave it on, you're going to have to get in the habit of coming back here and turning those into normal single quotes. Okay? So I wanted to point that out. I saw that, if you will, error, or I guess more precisely characteristic of my slide, and so I left it there on purpose to give us an opportunity to discuss that. Any questions so far? All right. So, declaring your own data types. Now let me be real upfront with you. What I'm about to show you initially, you're going to think, why would we ever want to do that? And I'll agree with you. What I'm going to show you up front is kind of like not very useful. But then I'm going to turn it a little bit and you'll see where it's useful. And then later on in the semester we're going to revisit this and you're going to see where this is extremely useful. But I don't blame you if up front you're thinking, why would I ever want to do this? So I have the types statement. Now, welcome to the world of ABAP. You will pull your hair out if you have any. I increasingly have less and less, but this semester, because ABAP developers love to do this. You have a type statement and you have a types statement. And they're two totally different things. We're going to see all kinds of examples of that this semester. And it is what it is. So the statement we are talking about here is the types statement. The types statement allows us to create our own data types that are in some way different than the standard data types. How do I do this? Well, keyword types, and here's an exact example of what I just was talking about here. Key name types, the name of the data type we want to create, employee ID, social security number, my favorite cat name. Types, the name of the type, then the keyword type, and then your type specification. I think that when they, did this with the types and the type like that, I don't know if they, cackled evilly at that point, but, it's just one of these things where you would think they could have come up with a little bit better syntax there.
Literal translation from German or something?
It could be, yeah, for all I know, that's a very good point. So this can be used to give a standard type a more descriptive name, or for your application, or to specifically define variable composition. One of the problems with generic types is, if I say data X type I, and then I ask you, what kind of data is stored in X? All you can tell me is an integer. If I said data X type person age, well, you now can hazard a guess as to what kind of information is going to be stored in X. It's going to be the age of a person. So one of the things that having our own user-defined data types does for us, and employing them in programs, is it gives us an additional element of semantic value or semantic richness. If I define a data type called employee ID, and then had a line in my code that said data X, and X is a bad variable name to begin with. We never want to use it, but just for my example, if I said data X type employee ID, you would know that what's going to be stored in X is an employee ID. So types are actually useful for us for giving us that additional element of descriptiveness. So here we have some example type definitions, and you will notice I'm showing this to you with a chain statement. So types, user age, type I. Now you might say to me, why wouldn't I just use I when I create a data object? Why do I need a special type here? You're right. This is just an example of the syntax. Types ID code, type N, length 10. Well, now that's a little bit better, because I clearly have a little bit more in the way of a type definition there. Remember, N is a numeric string. So now if somewhere else in my program I did data ID type ID code, then I would know, oh, well, ID codes are always numeric strings of length 10. Types rate, type P, so now we're looking at a packed number, length 3, decimals 2. So this is a packed number of length 5, where 2 of those 5 digits are to the right of the decimal place. So this is the way we employ types definitions. Now, types cannot have user-specified default values as a part of the type statement. Later on in my program, I could do data X type ID code equals 1, 2, 3, 4, 5, 6, 7. That would be fine. But there is no, the type statement looks a lot like the data statement, but one element of distinction is there's no ability to specify a default value. Types definitions are local to a single program, but probably about halfway or so through the semester, we're going to make a visit to the ABAP dictionary. And we're going to show you how to put type definitions in the ABAP dictionary. Once a type definition is in the ABAP dictionary, it is now universal across the entire system, which means that you or anyone else can use that type definition in their program. And in fact, type definitions in the ABAP dictionary can be incredibly more precise than we can achieve with just a basic types statement. Any questions about this?
So if we were to use the clear on types, it would just default to whatever the ABAP default value is for that particular type?
Excellent point. Yeah, so I'd get, for user age, it would reset it to 0 because that's the default for data objects of type I. All right, I've already mentioned this, so we don't need to park on that slide. And we're not going to do this. I was going to have us write a real short program that created some data objects, but I don't think we need to do that. You can practice with that in the homework, the next homework assignment we're going to have, and we may review it a little bit on Wednesday. I would like to get to one more important point, and this will set us up for being able to actually do something meaningful in our programs. We can create a single data object that incorporates multiple data elements. In C, these are called structs. In, I think it's PHP calls them records. I forget what the Java equivalent of this is, but this is the idea where I have a single data object, but if you will, that one data object has different fields in it. We often use these when working with database tables because a record from a database table would be an example of this. So how do I create, let's say for example, I wanted to create a single data object that would let me store facts about a person. Instead of creating a data object for first name and then a separate data object for last name and then a separate data object for street and a separate data object for state, what if I wanted to create one data object that essentially had different fields for first name, last name, state, city, and so on? You've done things like this, I'm sure, in other programming languages. How do we do this? Well, the way we do this in ABAP is through the types statement. So, let's look at that. The syntax is as follows. Types, colon, and the colon here is required for reasons that will become obvious as we go along here, begin of, and then the name of whatever you want to call this structured data type. User info type, game player record type, whatever have you. Comma, and then I'm going to see a set of lines that list the name of the fields. So if we go with my example I put here on the whiteboard, I would have a first name field, a last name field, a state field, a city field, and so on. So this would be first name, type, and then from this point forward it just looks like a standard ABAP type or data statement. So this might be first name, type, string. Or it could be first name, type C, length 25. And then the next, and then at the end of that line I put a comma. And then the next field might be last name, type C, length 30, comma. Next one, state, type C, length 2, comma. City, type C, length 25. And however many fields I want to be a part of this structure, that's however many of these lines I have. Then when I'm done specifying all of the fields, then I'm going to have a comma at the end of the last one of those. My last line of code is end of, and then whatever I said the name of my structure was, followed by a period. So, types begin of username type. First, type C length 40, last type C length 40, end of username type. Yes, sir.
You have namespaces and scope on the type.
This is local to this program only. We will talk about, once again, going back to what I said before, if I install this type definition in the ABAP dictionary, it then becomes available throughout the system. Which means if I do that, then in that instance, I have to be very careful about what I name this type because of name collision. But at this point, it's local to my program, so I don't have to worry about that aspect of it.
You can have an ABAP file that has your custom objects in that.
You can do that. You can include things, for example, but the more common thing is if I'm creating something that's going to have utility beyond a single program, then I want to put in the ABAP dictionary so that I and other people can use it. Whoops. So I dropped this fact in here between the two text blocks here. The way I reference the fields is using a dash between the data object name and the field name. So let's look at this bottom block of code again. I'm creating a type definition called username type. And I don't care really whether you choose to use the underscore as I have done here, but my suggestion to you is make sure that your type definitions semantically make it clear that this is a type that is being created to make your code read clear. If this was types begin of username, it makes it seem like this is a data object, but it's not. This is a type definition here at the top. So I create the type definition, and then a mistake that you will make if you are not careful is exactly what I just said. After I create the type, I haven't created a data object based on that type. I do that with a data statement. Data friend name type, username type. So my syntax here is just like the other variations we've seen on the data statement. The key being there's no length or decimals or anything like that viable here. We can only put the name of our user-defined data type. Well then, when I want to start putting things into this structure, I use the name of the data object, which in this case is friend name, a dash, and then the name of the field. So if I want to set the first name to Robert, you see the code to do that. If I want to set the last name to Millipede, which I don't know if I've ever met anyone with that as their last name, but nonetheless, if I want to set it to Millipede, this is the way I do that. Now, we could have created on our slide here a structure with 7 fields or 12 fields or whatever have you, but it would just look the same and just take up more space on the slide. So I didn't show you one of that, but I will say it definitely is more common to see user-defined data types of structures that have more than just 2 fields to it. It's typically going to be something like I put up here on the whiteboard: first name, last name, street address, city, phone number, zip code, whatever have you. So these structures are in fact something that are very, very useful to us in our programming. Any questions about this? All right, let me see what we have next up on the agenda. Let's do this. I'm going to skip over a slide and we'll come back to it. I do have constants. Constants look like data statements. The only distinction being, well, there being two important distinctions. One, we have the keyword constant. And if you think about it, I have to have a value statement with a constant because I'm setting the value of the constant upon creation. So if I don't have a value clause, I have a constant that's set to nothing, which is of no use to me at all. So here's a couple examples of that constant, a const, type D, value 19681214, and so on. Okay? So we have about 8 or so minutes left. Let's back up to this slide right here, which was going to call for us to write a real quick program together. So let's do that. So design or define a structure capable of storing a complete address. After doing so, create the structure and store data in it. Okay, so that seems pretty straightforward. So let's go to our ABAP editor, and I think I mentioned this at the outset. I tried to make the text a little bit bigger. Hopefully that's helpful, but we're going to see it may inhibit our ability to write long lines of code, but we'll just see how it goes. So I start with the keyword types. This has to be a chain statement, and then begin of, and I don't know if you've seen this already, but notice as soon as I start typing begin of, the editor guesses what I'm getting ready to type, and it usually does a pretty good job of it. If you want what it's suggesting, just hit the tab key. So begin of, and I have to give this a name, so I'll call this address underscore type, comma, and notice when I hit the return, the editor was smart enough to automatically indent this, because it recognizes now I'm giving you the fields that are going to be a part of this. I've been known to do this a few different ways. Sometimes in my program I'll do something like this. Okay, I know I want there to be a street. I know I want there to be a city. I know I want there to be a state. And I know I want there to be a zip code. So like sometimes I'll just go through and list the fields and think about my design a little bit, and then I'll go back up and fill in the rest of the syntax. And I'll say to myself, okay, street, well, that's going to be a character string, so I'll do type, C, and then I have to ask myself what would be a reasonable length. I'm not putting this in a database, so I don't have any other thing to reference. I just have to think about this on my own, and I'm going to have 50 be the length of a street. That's a totally arbitrary number. City, similar thing here, type C, length, and maybe I just say, for the sake of consistency, let's make that 50 characters too. And then state, type C, but here I'm going to go with the 2-letter abbreviation, so length 2 looks pretty good. Zip, type, what would be my data type here?
Depends if you want the whole zip or just the...
That's a really good point. Do I want, I think it's called zip plus 4, or do I just want the zip? And if I wanted just the zip, then I probably would do type N, length 5. If I were going to do zip plus 4, I would have to, if I want to store the dash as a part of that, I probably would do type C, length 10 to give the user the ability to type that in. I'll leave it using just this version just for the sake of having that line of code be a little bit different. And now I'm done. So on the last line, I have to hit backspace to get back to align this the way I want it to, and then end of address type period. So just a couple of things to note here. note the way this is indented. This is the way we want it to be indented. Notice some other things about this as well. In terms of the IDE, we get this little line around this particular structure. I don't find that I have to do this very often, but what this is useful for is if you're writing a really long program and you want to conserve screen real estate, you can like roll that up if you want to, and then unroll it. Just a feature of the IDE. So I've now defined this. Well, let's very quickly here actually make use of this. So remember, I have to create a data object, data, user address, type, address type. So now I have one data object. And then this is going to look a lot like the example that's on the slide. User address street equals Mulberry. User address dash city equals Johnson City. Now, I did not turn this on, but I noted in going through some of the IDE controls, there is the ability to, right now, ABAP will do keyword hinting. You can turn on, and I forget the exact terminology for it, context-sensitive hinting, which leads me to believe that if we turn that on, we might be able to type user address dash and have it prompt us with the different fields, and we could pick it that way instead of having to type state like we're having to do here. So that's something you might want to play around with in your IDE to see if you want to turn on that degree of code hinting. And if any of you do that, let me know how it works. Well, this is a syntactically valid program. It creates absolutely no output at this point, and I didn't define a zip code, but let's do a syntax check. And it does say that no syntax errors are found, so we have very good code here so far. We need to, when we get together next time, bring together our coverage of the data statement with the write statement to talk about how would we output a user address in this context. And so that will be one of the things that we look at for next week. I don't think that I will give you a homework program this week, but for next week, you should expect a homework program. And I'll tell you that what is very common in this class is not to have a program, but have like 3 or 4 pretty small programs that you have to write. And so expect that to be something that you get next week. Any questions here before we have to head out? Yes, sir.
Is there, so it's completely valid for you to not enter a zip code for that?
Yes. It's just like I could create a data object and never actually use it in my program.
Is there any way for you to make that mandatory?
No. No. Now, there would be ways if I'm taking data from an end user to require them to enter a zip code. I can do things like that. But as far as the kind of code that we were writing in that program, there's no way for me to make that mandatory. Have a good afternoon, or good morning still at this point, everyone. If you didn't sign in, please make sure you do so. I don't know where the sign-up sheet wound up.